If you haven't done so yet, please pause the video and try to answer this question on your own before listening on. For part A, we're going to consider Ohm's law, which of course tells us that the potential difference across two ends is equal to the current multiplied by the resistance. Now, this question is asking us for the required resistance in the coil, so we want to isolate the resistance R in this equation. So let's go ahead and divide both sides of the equation by the current I. And we can see, therefore, the resistance equals the potential difference divided by the current. We simply have to plug in the given potential difference, which is stated right here, and then the current is also stated, both of which are in their standard units. So let's fill them in. And when we plug that into our calculators, we should get approximately 13.0 ohms. So this would be the correct answer for the resistance of part A. Now part B wants the length of the wire that would be used to wind the coil, and so we're going to examine a relationship between resistance and length. And in this chapter we have learned that resistance is equal to a constant multiplied by the length of the wire divided by its cross-sectional area. Again, we want to calculate the length, so we'll solve this equation for the length L, and to do that we can multiply both sides of the equation by the area A, so it cancels on the right side. And then we can divide both sides of the equation by this constant, which is the Greek letter rho, and that way it'll cancel out on the right-hand side. Now, the resistance, capital R, we've already calculated in part A, so that's relatively straightforward. We have this area term right here, and for most circumstances we can assume that the wires are cylindrical, which means that the end of the wire is a circle, and we know that the area of a circle is pi times the radius squared. So for this cross-sectional area A, we're going to substitute in pi r squared. And then for the denominator, we have that constant rho, and that value will depend on the material that the wire is made of. In this case, the wire is made from nichrome. So we'd have to go into the table of this chapter and look up the resistivity value for nichrome, which turns out to be 150 times 10 to the minus 8 ohm meters. So again, this is a constant that you would have to look up in the table of this chapter for nichrome wire. Now that we have all the values for the radius and the resistivity, as well as the resistance, we can plug in. Don't forget to change your radius into meters by multiplying it by 10 to the minus 3. So let's go ahead and plug in all the known values. And when we compute that, we should get approximately 17.0 meters for the length of the wire. So this is the correct answer to part B. Thanks for watching. If you liked that video, please click the thumbs up and also subscribe so you can stay tuned for other videos. Remember that you can send in your own question to the email address shown on the screen, and I'll do my best to post the answer to it on YouTube.